Alright, hi everybody. For those who don't know me, my name is Jason Stangroome. I've been a consultant with Redify for over 4 years now. I've been working for a long time as a developer, but I have a strong infrastructure background and I have a passion for reliably shipping the software that I help to build. I've been following PowerShell since it started as a proof of concept called Monad back in 2005. And I think it was its novel, object-oriented based approach as opposed to essentially fragile string parsing that it immediately drew me to it. I'm also a primary contributor to an open source project called TFS Deployer, which is recently deprecated. But it was responsible for taking team builds from TFS and deploying them to an environment using PowerShell. And so as part of building that, I've had a lot of experience trying to get C# and PowerShell to play nicely together. Enough about me. Let's look at PowerShell version 3 for developers. So I'm going to cover a few things today. Firstly, why should you care? I'm going to have a look at what's different between versions 2 and versions 3 of PowerShell, but I won't be able to cover prior to that. So a little bit of prior knowledge would be great, but you shouldn't be left behind without it. And then I'm going to look at various ways of having C# interact with PowerShell, where it's C# inside, extending it, hosting it, why you would do that, and have a look at some code on how you would do that. So as a developer, you're not working with the typical infrastructure style projects and products where Microsoft is focusing all their PowerShell marketing. You're not dealing with Active Directory or Exchange on a daily basis, so you're not hitting that. But you are getting it in other ways. NuGet, for example, has become the way to do dependency management on the Microsoft platform recently. The community has well and truly embraced it, and all your favorite libraries are on there now, some of them exclusively so. Microsoft has made ASP.NET MVC3 and 4 primarily delivered through NuGet in part of Visual Studio 2012. Basically it's there. The NuGet package manager console in Visual Studio is all PowerShell, and so if you need to drop down and import a particular version of a package, you have to be familiar with that. And if you're creating any of your own packages and you need to customize anything beyond copying a library into a reference, then you'll end up with various PowerShell scripts in your package to extend that behavior. The other thing is the common engineering criteria. For those of you who aren't familiar with this, this is Microsoft's equivalent of the done definition for all their server products. Basically, it now says that any server product shipping must ship with PowerShell support. So it's certainly not going away, and we've just seen Windows Server 2012 ship with over 3,000 commandlets in the box for managing everything from Active Directory, IIS, disk partitioning, etc. And of course, we see that flow through into their cloud offering as well, with all the Azure management and deployment stuff, which you're likely to encounter as a developer working on those platforms. The other reason where you might be looking at it is console applications. You've probably written a number of console applications. You might need to take some arguments, and inevitably you end up coding up everything to deal with argument parsing. Check for slashes or dashes, whichever one you choose. You might remember to check for case insensitivity. If you need to parse pairs, do you separate them by space equals? And everybody implements it differently. Unix and Linux have had the standard getOptC library since the 80s, which makes this nice and easy for everyone, but still Windows platform, everyone's doing it differently. You do it in PowerShell, the whole parameter system is in the box. You just set it up as, I want to take this parameter, this type, it handles the rest. And that even includes generating the usage text. Too many apps I've used have hidden parameters that don't show up when you go /?. But there's more than that. Again, in PowerShell, things like prompting for confirmation when you do a sensitive operation, and allowing the user to, say, set a flag to override that confirmation. Writing progress or thing, whatever operation you're doing happens, rather than having a spinning pipe / hyphen or doing dots on the screen. Again, PowerShell handles all that for you through a simple write progress commandlet. And of course, requesting credentials securely. You don't have to, set up a console read that doesn't print characters to the screen as people type their password in. So there's a lot of reasons why you'd be looking at PowerShell instead of writing a console application. And the last one I'll touch on is Octopus Deploy, which is a deployment solution. It kind of replaces the TFS deploy that I used to work on. This one's not written by me. It might be a good reason in itself. But it's also built on NuGet packages. And so it has a lot of conventions for deploying websites and such. But as soon as you move outside those conventions, you extend it through PowerShell scripting. So assuming that I've convinced you that you should be using PowerShell in some form, or you already are, how might you use it or use it more? Common scenario I've come across is for helping to configure your development environment. For example, you've got to switch branches to patch it. Websites to the new folder paths. Having that scripted is nice. Certain things that your application might be dependent on to run in your environment, like environment settings or having a local database set up. Getting that all in a script, checked into the branch root and source control, and then run the script, his dev machine's ready to go. That's a handy way to do it. Script out into the how and the why. The how part then becomes useful as a way to automate the deployment of your app into your test environment, your staging environment, and your production environment. Developer tooling is another useful one. I find myself falling into PowerShell scripts to solve little developer problems every now and then. Project I'm on at the moment, I wrote a PowerShell script to go through source control, find all the solutions, project references, NuGet packages, and put it in an XML file that Visual Studio happily renders as a graph, so that we can easily see all our dependencies across all of the system.
Keep going.
So the other thing is prototyping. Again, you might whip up a console application, and instead of that, you can drop to PowerShell. You don't have to create a new project. See how it works and sort of play around very interactively. It can be a nice quick way to prototype stuff. The real obvious one, though, is writing management tools for your applications. And this is pretty much how most of the PowerShell users of the world experience PowerShell, is they're working with Active Directory, Exchange, etc. And it's all managed through PowerShell commandlets to configure the system, query information about it. And so you're going to get a generation of IT pros that start to expect this of every system they work with. And so providing that kind of functionality for your application is an obvious direction to go. So you're going to use it for one of those ways. What's changed in version 3? It's now on .NET Framework 4.5, and it's using the dynamic language runtime under the hood. PowerShell version 2 was on the CLR2, basically only went up to .NET 3.5. There were some tricks to get it to run on .NET 4, but they were unsupported, and a number of modules would break when you tried to do it. PowerShell v3 has actually been pretty sneaky about how they've done the .NET Framework versions. Because CLR2 and CLR4 have different GACs, they've been able to ship PowerShell 2 and 3 on the same box, and depending on which CLR it runs under, based on either a flag on the command line when you run PowerShell exe, or if you're hosting it yourself, you'll get PowerShell 3 or PowerShell 2 in your session. And the way PowerShell extends objects, because you can have any old object.
Sorry,
yeah?
Did you get PowerShell 2 or 3? What was that slight distinction?
Okay, so to do PowerShell 2 or 3, standard, you just run PowerShell exe-version 2 or version 3. Yep. If you're hosting it yourself, it depends on the framework version that your app is written in. If you're 2.0 to 3.5, it'll be PowerShell 2. If you're 4.0, 4.5, you'll get PowerShell 3. Presuming you have it installed, of course. So, as I was saying, so PowerShell's object model basically allows you to take concrete classes and add your own properties and methods to it. In V2, based on CLR, it basically ended up with a wrapper class around everything to simulate that. They've been able to simplify a lot of that now and use dynamic objects because they're now on the DLR. The other nice thing is it's installed by default in Windows 8. So anyone running a modern operating system is going to have it ready to go. It's also pretty well covered in the other versions as well. So obviously Server 2012 being the same OS, essentially. Windows 7 Service Pack 1, Server 2008 R2 SP1, Server 2008 SP2, all supported download and install it. Windows XP and Windows Vista, no. You'll have to settle for PowerShell 2 there for the time being. The other awesome default is that remoting is already configured. It's always on by default on Server 2012 machines, typically because you're expected to be managing servers through PowerShell and remotely, and lots of them. But Windows 8, the remoting is only configured by default when you join to a domain. So you get all those security benefits when you're just running a laptop like me, connected to the internet, you're not exposing remoting to the world. And the IC got a whole lot smarter. So the integrated scripting environment that was introduced in PowerShell v2, it had tab completion, but now you get the experience of the Visual Studio-esque drop-down lists wherever you're typing, showing you all your options. And you'll get to see that later in the talk when I demo some code. There's a couple other minor things that I really like as a developer that they brought along. There's a whole bunch of commandlets, obviously, but two that are really handy, especially when prototyping. They've got convert to and from JSON commandlets. So any object you're playing with in PowerShell, you can spit out JSON and back the other way. That's JavaScript object notation, not me. And the other one is invoke REST method. You just point it at a URL, say I want to do a get, a put, whatever, and it'll go and call that and bring the translation back, and if it comes back as JSON or XML, it just renders it into a PowerShell object for you. Really nice. A few other things I want to go into a little bit more depth that have changed. PowerShell version 1 and version 2, you always had write host, write output, write error, write warning, etc. Anytime someone wanted to capture the entire output of a script into a log file, really challenging. Basically because write host is not captured by anything except start transcript, which only works in PowerShell exe and nowhere else, which is always fun. But now, they've implemented all the standard redirect operators, a bit of an extension of what you might have got used to in the batch script world. So you can individually pick write output, error, warning, verbose debug, all of them combined, and pipe them out to a file. If you're still writing write host, stop it, you're hurting kittens. Don Jones has an excellent blog post on the topic. Using write host is the PowerShell equivalent of using tables in HTML to do layout. Yeah, I think that's probably the best way to put it. Parsing, oh, this one I love. So much in PowerShell, people are trying to call out to other apps or batch scripts or whatever. And they get into a whole knot trying to work out the syntax so that the command line goes through properly. iCackles was a common one, the command line tool for querying and setting ACLs. Because you normally put parentheses around the permission that you're defining, PowerShell thinks that that's a sub-expression, and so you have to escape the parentheses with backticks, and all sorts of fun like that. And people get into a big knot. This operator, you stick it anywhere on the command line, everything that follows PowerShell will leave it alone, and it will not try to parse it with its variable substitution or expression evaluation, and so it can make stuff really easy. However, still a couple of tips. Whatever you're doing, be familiar with sysinternal's process monitor, or procmon. You set it up with a filter to only show operations that contain the word process, And then anytime you run a command line that's supposedly building a set of arguments, it'll show you exactly what got passed to the application. And so you can then see, that's where my code is wrong, as opposed to guessing and trying to understand the error messages coming back from the application you're calling. And the other tip is use the start process commandlet where you can. It takes an argument list parameter, which is an array, and the elements of that array align directly with the args array of the main method in the application you're calling. So it's very one-to-one. You know exactly what's passing where. You don't have to worry about quoting and escaping as well. So that's very helpful. Member enumeration. I got a few nice little tips in there in V3. So the first block here is V2. You've called get process. You've got a whole bunch of processes that are currently running on your computer back, and you iterate through all of them to get the process name and just let that fall out to the default output. In PowerShell version 3, you can actually call that property getter on the collection. And what PowerShell does is realizes that the collection object itself doesn't have a process name property, and so it checks if the items in the collection have it, and then it will just go through each one of them and call that property getter for you, which is a nice typing saver. It also goes the other way around. If you called get process and you got multiple items back, you'd get an array. If you call get process and there's only one matching item, you get a scalar value of that one item. It's not encapsulated in an array. And so if you were trying to access the first item in the array and you only got one, you might use the indexer of square brackets 0. That now works against scalars as well. So they've gone, OK, look, this is an array, but because you've referenced index 0, I can assume you're referring to the object itself. So that's a nice, nice handy point. And again, foreach commandlet, where you use, or the where object commandlet, or anything where you've got the $_ iterator variable, you can now also use $PS item if it makes it a bit friendlier rather than looking at underscores.
I'm going to ask a really silly question. So we've got an array of get processes, and I can call a method on each of those just with that one line.
That's correct, yeah. So get process will return an array of processes, and in one line you could call .kill.
Rather than all of that.
Instead of writing a for loop, you could just write .kill and wipe out everything on your system.
That's awesome.
Yeah.
Dangerous.
Fun.
It's awesome.
Is there a get file.delete?
Yes. Yes, you can delete all your files the same way. You're welcome to try that one at home.
That's cool, man.
Creating new objects in PowerShell. PowerShell doesn't have a class system, but you can just spin up an object and throw whatever properties and values you want on it, and methods if you like. The V2 way was to use new object, create a PS object, and just pass a hash table through of all the names and values. In V3, a little bit shorter on the typing. Instead of calling new object, you just have your hash table, and you just cast it to a PS object, and it goes, PS custom object, sorry, and it just spins up a new object with all those properties and values on it. It also does it with existing types. So you can just have a hash table, and then in this case, I'm casting it to the system drawing point. It just creates a new point, and then goes to the property setters and just sets all those properties for you. There's a couple of others. Hash tables, as we're using here, the order that you insert keys isn't necessarily the order that they come back because of hashing, but .NET has an ordered hash table. So now you can just cast your hash table to ordered in square brackets, much like we've got PS custom object here, and it will remain ordered as you add items to it. So that's also very helpful. This is one that I like, but I'm not sure how to use it yet effectively. You might have seen in a script or a function you define a parameter block. And in that parameter block you can say the parameter is required. You can set some validation. Here I've got a validation set saying that the string must be either red or blue or it'll fail. And you've got other ones like validator regex, validator number range, etc. I can apply that directly to any variable now. It doesn't have to be a parameter. I can just have a local function scoped variable, and I put string on it to make sure it's always a string, and I put validate set on it. And it doesn't matter where in the code you try and set that to yellow, it won't let you. So that's kind of handy. New in V3. You'll also note that I've italicized the true on mandatory equals there. Anything in a parameter attribute where you're saying mandatory is this, position is that, the trues can be left off now. So just a little bit less on the typing. There's some other new features. I won't go into these ones in great depth. PowerShell workflow, basically a way to get PowerShell scripts to do long-running tasks, potentially across multiple machines, surviving reboots. It's just PowerShell inside Windows Workflow Foundation. PowerShell Web Access, this one's really cool. You can get a PowerShell console in your browser window. And when you log into it, you basically nominate the machine on the network that's hosting PowerShell Web Access that you'd like a remoting session to. And then in your browser window, you've just got an active PowerShell remoting session to that box. Obviously, set it up securely, but nice. Management OData, another one that I like, but I haven't found a need for it yet. You can basically expose a bunch of PowerShell commandlets running on a server somewhere through a REST-based OData service. So you can do various GET calls for certain, in REST scenario, it's going to be URI resources, and that's going to call a GET noun on the PowerShell commandlet. You set up some mappings. Can be a nice way to do a very thin layer of management rather than writing a whole PowerShell module over your app. And scheduled jobs, which is basically a really nice PowerShell wrapper around the Windows task scheduler for running other PowerShell commands and scripts. But you don't have to worry about trying to get the commands to PowerShell.exe right in the task scheduler. It just deals with it for you.
So we on a previous job we used task scheduler heaps. So what's the difference here?
Specifically for running PowerShell scripts from the task scheduler without having to get the syntax to PowerShell.exe to run your script with the right parameters, which can be fiddly. Under the hood, it's actually encoding your commands into base64 and then just passing that as one argument to PowerShell.exe, so it doesn't have to worry about command line parsing, all that sort of stuff.
Okay, so if I go into task scheduler, will my jobs still appear in there? Or? They will appear there.
Any jobs you create through the PowerShell commandlet system to create jobs will appear in the task scheduler. The other way around is not true. If you just go and create one in the task scheduler that looks similar to the way PowerShell has set it up, it won't reveal it when you say, hey, PowerShell, get scheduled jobs. I haven't looked into the details of that, but that's just one of the things that they point out. And I guess the other one that everyone comes across is the help system in PowerShell v3 is now not shipped in the box. You have to call update help to download it from Microsoft and get it on your machine. Not a big deal, but it means that they can ship updates to the documentation much more rapidly than they can ship updates to the OS. So that's what's changed in PowerShell v3. Let's have a look about why we might try and use C# from inside PowerShell. Much as PowerShell can do, and as many things it can integrate with, like the .NET framework itself, WMI, COM, pinvoke is one of those situations where PowerShell can't do it itself. Again, I said before, PowerShell doesn't have a class system. Enumerations basically fall under that. So my previous example with the validate set red and blue is nice, but actually having an enum that you can set as parameter types, function types, and get the IntelliSense completion is nice as well. And obviously classes. So if you want to set up, well, you can add properties and methods to any object in PowerShell. It's to that object instance. If you want to set up a class so that everything you create of it will have those same methods and properties, you're going to have to fall back to C#. With the possible exception of importing a module, the import module commandlet has an as custom object property, which basically brings all the commandlets in that module in as one object with those functions as as functions on that object. So it's sort of a way to create a class. So might show you how you do that. All right, so I'm going to start with the enumerations. What I have here is an add type block with a bunch of C# just stuck inside it. And all I'm doing is declaring an enum. And you'll notice the last one's commented out. And then I can, a bit further down, declare a function where one of the types is that enumeration I've just declared. And I just do a quick test that it ends with consultant and return that back. So if I remove that comment there, and we run the script, you see that a senior developer is not a consultant because we get false back. Pretty obvious. But this is where it gets handy. So just gonna. So here's our lovely IntelliSense in the V3 IC, and because of the enum, I'm now getting all that completion. So I can go, yep, lead consultant, there we go. And now I get false true, because there was. And of course, you can use it for casting. So I'm just going to take index 2, and we get back senior consultant. Lovely. One of the interesting things that is going on here is that every time I'm running this script, it's running add type, this string, but it's not complaining that I've already got that type. What it's doing is it's looking at the hash of the string that you've created and looking that up and going, I've already done that one. So if I go in here and uncomment Uber consultant, which is my next promotion hopefully, and we run that, we get a nice big error which basically says, sorry, that type already exists. You can't declare the same thing twice. If I flick that back, we're back to good again because it's recognised the hash. So that's.
Sorry, I didn't hear why that didn't work. Sorry.
Okay, so first part was it's recognising the hash of the string to realise whether you've tried to compile that already. When I change the hash of the string by changing the content of the string, it tries to recompile it. And because the scope of that type is the PowerShell session, when it tries to recompile another thing with exactly the same name but with slightly different contents, it says there's already a tech roles enumeration defined in this app domain and fails. So when you're debugging, that can be a little bit annoying, but that's why it happens. When I'm debugging, I usually end up at public enum tech roles number 14 by the time I've got it right, and then I just restart the IC. The other part is we'll do the p invoke. This one's really simple, but has a nice side effect. So the first line is just my convention of getting the path to the current script that's running. I call it PS script root because if you implement a PowerShell module using PowerShell, that variable is automatically defined for you and refers to the path that the module is at. So when I use scripts, I declare it as well. I actually think version 3 of PowerShell defines that for you for scripts as well, but I've encountered a bug where it sometimes doesn't work in the ISE. So there it is. What we're really doing here that's important is I'm saying take the pinvoke CS file that's in the same directory as this script and add the type that way. And I've got that CS file here without any lovely syntax highlighting, but because it's a separate file, this is a scenario where you could have these CS files open in Visual Studio, work with them with all your resharper fun and project system, and then back in PowerShell, you just import it like that and just have the files coexist. And so after declaring a shell32 class with a isUser and admin pinvoke call, I just call it via the standard PowerShell static class call, and surprise, surprise, I'm not an admin. That was pretty boring demo, but I think it's the point across that you can get the code out. It doesn't have to live in the same file. And the last one is classes. So a little bit of a contrived example here. I might skip past the class first. I've got here a tech A and a tech B, two objects using the object creation syntax I showed as the old V2 way earlier in the talk. And they both have the name Jason. And then I'm creating a hash table where each of those objects is a key in the hash table. And the nature of hash tables is you can't have duplicate keys normally. But of course, I run that, and it's happy. It creates the hash table and puts them both in there. And that's because PowerShell has no idea that these are the same object, because just because they've got the same properties and whatever. It's just using the base object equals and get hash code, which is based on the reference. So not a lot of good there. So what I've done up the top here is I've created my own tech person class. It has a name property, and I've got an overridden equals and get hash code so that the equivalence of this class to another instance is based on the name and not the reference of the object. So then I can go along here, use my custom type. To start with, I'm creating a Jason and a Bob, still setting up the hash table as before, and it's still happy. And then I change one of these to be Jason. Ideally spell it properly. And then it complains about duplicate keys. So that's handy when you're dealing with hash tables and you want stuff to find duplicates and you want a custom type and all that sort of stuff. There was actually a bug in that C# code, so don't copy it. It allows you to change the name, which would change the hash code, which would seriously upset a hash table that already contained that object. You won't get it back. All right, so that was C# inside PowerShell. Any questions before I proceed? All good? All right. So let's have a look at C# extending PowerShell. So what we're talking about here is writing modules for PowerShell in C# as opposed to writing them in PowerShell itself. PowerShell, you take a script that's a PS1, you make it a PSM1 file, you call import module on it, and for the most part, you've written a module. You can go a bit further to make it nice, but that's essentially it. But firstly, why would you do it in C#? Now, I've blogged about this previously, but I can sort of summarize it as there's been a bunch of PowerShell performance improvements in version 3, there's nothing quite like jittered compiled code for dealing with large quantities of data or complex operations, because essentially PowerShell is still interpreted for the most part. Developer tools. I love the ISE, it's my PowerShell scripting tool of choice, but there's no refactoring support. You end up becoming a keyboard jockey and developing some kind of RSI. When you get a large script, you need to separate out. And of course, the testing tools are a lot more mature and the mocking tools are a lot more mature in the C# world. They're coming along in PowerShell, but I don't think they're quite there yet.
So are you saying there's testing tools and mocking tools in PowerShell?
Yeah, PSMock or SMock is a recently released PowerShell mocking tool. It's actually not a bad implementation of it. There's about 3 or 4 testing frameworks for PowerShell of varying capabilities. Experience, though, is probably the main one. Unless you spend a lot of time in PowerShell, you might find yourself just more comfortable writing stuff out in C#. And especially if you're working with, say, developing a management module for an application that you've developed in C#, then taking that same skill set across makes a lot of sense. There's a few other things like, yes?
Sorry, this is all new to me. Can you actually take a DLL, like you've written a DLL using C#, can you actually call classes or create classes or methods from within that?
Yep, so just with PowerShell, from version 1, it's built on the .NET framework, and while it has its own set of commandlets and so on, the full .NET framework is available at your disposal, plus anything that you've written yourself or grabbed from a third-party library. The add type command that I was using earlier in the demo and passing in a CS file or a text of some code, I can also give it a path property and just point it at a DLL. Or I can give it an assembly name property and refer to a qualified assembly name of something that lives in the GAC. And that'll then be loaded into PowerShell, and then you can create new instances of any of those classes, or you can call static methods on any of those classes. The full .NET world is available to you from PowerShell, which is why I was saying earlier that it is such a compelling alternative to whipping up a console application, because you've got the same tools at your disposal. The strongly typed nature of working with C# as well can also be very handy for people that are more comfortable with that. Whereas PowerShell's it's got a type coercion system, so I wouldn't quite say it's strictly typed or it's dynamically typed. It's type coercion. It has its own list of funky rules. So we'll have a look at some code. I should have a Visual Studio instance running here with, oh yep, exactly what I want to show. Now, App Harbor. Kind of like Azure, but done right. Is that what they call it? A little while ago, they put out a console app for calling the App Harbor API. And that just really annoyed me. I was like, this is the perfect target for writing a PowerShell commandlet. So I decided to whip one up and open source it. I got about a couple of methods into it and then went back to the day-to-day duties of life. But it's a great demo. So what I've got to start with is the connect App Harbor commandlet. And we want to collapse a few of these windows for readability. And bump that font size up for you. There we go. All right, so probably the first thing I should demonstrate is that we brought in a reference. System.management.automation. It says PowerShell all over it, right? That's in C, program files, SDKs, reference assemblies, Microsoft PowerShell. Yeah, you reference that one, and you get most of what you need for PowerShell out of that. And then you need to inherit from PS commandlet. It gives you a bunch of the base stuff. When you write PowerShell scripts, and you write a function, and you put a commandlet binding attribute on your function, you actually get a $PS commandlet variable in the scope of your function. That variable and this base class, same thing. So you get access to some of the underhood PowerShell functions to make it easier to write these things. I'm starting off by declaring an argument to this commandlet, whereas that would have been a parameter variable in the function. Here, it's actually a property on the class. And I decorate it much the same with the parameter attribute. It's mandatory. It's the first position if they don't want to set the name. I'm typing it as a no. A subtle difference here. It's of type PS credential, which is the type that PowerShell passes around for securely handing credentials around, usernames, passwords, etc. The credential attribute is a transformation attribute. Basically says to PowerShell, because of its type coercion system, if someone passes something to the credential parameter at the command line and it isn't a PS credential, talk to the class that implements the credential attribute to work out how we can convert it to a PS credential. And one of the things that'll do is go, okay, look, it's a string you've given me. It happens to just be a username. I'll pop up a credentials dialog with the username pre-filled and ask them for the password. And so, I don't have to deal with that. I just go, hey, it's a credential. Thanks. And then we get into the actual core of it. A lot of the time when you write a function in PowerShell, if you don't do anything specific other than just say, hey, this is a function, the body of your function actually belongs to, I think it's the end block. All PowerShell commandlets have a begin block, a process block, and an end block. And it's got to do with pipelining, where you chain all your commands together and the objects flow through them. The begin block obviously gets called once before your command does anything in the pipeline. It gets called, process block gets called once for every object that flows through, and then the end block gets called at the very end. Who would have thought? And so to do that in C#, the commandlet base class that you're overriding has these on it, and you just override them and implement them. So because I'm writing the connect to App Harbor commandlet here, I'm not worried about piping stuff in at this point. I don't know, no need to support that. So I'm just writing it in the begin processing. And so I take the credential property that's come in, do a bunch of App Harbor API stuff. And if an error comes back from the App Harbor API, then I use the write error, which is the equivalent of the write error PowerShell commandlet, and I send through an error record, so it's a nice strongly typed thing with a bunch of details about what went wrong rather than just a string. Otherwise, I set up my module so that the API is already connected. That's all App Harbor specific stuff. The other class that is then interesting is the get application commandlet. So once you're connected to App Harbor with your credentials, you can then say, hey, what applications do I have registered for my account? And to simplify things, I've put a lot of the authentication management behind in a base class, which also inherits from PS commandlet. It just gives me this ensure authenticated method, keep it a bit cleaner. Another good reason for using C# to write PowerShell commandlets. Quite often you might find that in your module you want a fair number of your commandlets to have a common set of parameters. In PowerShell itself, every commandlet gets verbose, debug, error, action. I think there's about 5 of them. And then, App Harbor, maybe I want to give every commandlet the ability to specify the application itself, which would make sense when I get to the commandlets that deal with setting up applications. So rather than implementing the code for that on each one, I just put it in a base class. You wouldn't be able to do that in PowerShell. Writing for a module, you'd have to copy and paste a lot of code, and that's not fun. So a couple of new things here we didn't see in the previous one. I've got an application ID property, it's a parameter. I've got a couple of aliases defined on it, so they can call application ID slug ID. I've used those aliases in this case so that I can make full use of the pipeline. Some of the objects that are coming back from App Harbor, I'm treating them fairly raw and just letting them flow through. In App Harbor, while you ask for something by application ID, when it comes back, it calls it the slug property. But by saying that slug is the same as the application ID, if someone pipes one of those objects into this command, PowerShell is going to go, oh, slug, that's the same as the application ID. OK, I'm going to set that parameter to the value of that property. And the value from pipeline is saying that, yeah, this can be fed from the pipeline. And then, yeah, so I've got the begin processing, which only does the authenticated. And because this is a pipelinable commandlet, all the real work happens in the process record. In this case, if they don't specify an application ID, I assume they want all of them, and I go and get all of them. And if they specify one or more application IDs, then I go through each one and go and ask for them and just write them back. So that's all pretty boring. I can show you it actually running, prove that it does actually work. And it's one of those ones I probably should have prepared earlier. Let's hope that works. OK, so I've just got this script sitting very close to that project. Goes up a couple of levels and goes and finds the PSD1 file, which I should show you. The other neat thing that you need to do for a C# PowerShell module is to create a PSD1 or a PowerShell module manifest, which basically just says some dumb things like this is what version it is, this is who wrote it. These are the DLLs you have to load to implement this module. As you can see, it's basically a PowerShell hash table. And PowerShell has a commandlet built in called new module manifest, which will ask you for all the right bits and generate this file for you. And then all I do is stick it in the project and set it to copy to output, so it ends up sitting next to the DLL. And yep, so what I'm going to do here is import the module, call connect to App Harbor to authenticate, and then call AH application to get the list of applications. So let's go run on that one. All right. So here's a case where I didn't actually pass any credentials to connect App Harbor, but it's mandatory. It's seen that it's a credential and gone, hey, you're running interactively, here's a GUI. So just fill that one in. And with any luck, I've got my password floating around here somewhere. Don't look. And it's thinking, and hopefully I'm still on the internet, and I am, and bang. And there we go. It went all the way off to App Harbor and brought back the fact that I have a get module application running up there on the Amazon Web Services region, and that's the URL. All formatted and truncated so you can't ruin my demo before I finish it. So that's how you write a module in C# for PowerShell. The next step is hosting PowerShell. Why would you do that? It's the old argument of hosting a language in an app. Add scripting. You want to be Excel. You want to have VBA. It's, yeah, all right. But you do see some examples, like the NuGet package manager in Visual Studio is basically hosting PowerShell in a tool window in Visual Studio. Studio Shell, which is on my list to play with, I can't wait. A bunch of guys have developed basically a plugin for Visual Studio so that instead of having to write Visual Studio macros and deal with the DTE COM objects, they've wrapped it all up in PowerShell commandlets. So you can automate your IDE through a few PowerShell commandlets. One of the examples on their website, I think, is querying the mercurial status of all your files in one line through PowerShell. It's cool. The other reasons why you might do it is if you want to leverage functionality that's in PowerShell, but perhaps not in the .NET framework. My favorite example, which is a little contrived but has actually been useful, is CSVs. Everybody's probably written, much like their console arguments parser, they've written a way to write CSV files out. Sometimes they get the coding right, sometimes they get the commas right. A lot of the time they get one of them wrong. Or you go and download a third-party NuGet package or whatever that does CSVs. PowerShell has CSV importing and exporting in the box. Convert to CSV, export CSV, import, convert from. And it's proven. You just give it a bunch of objects and it makes a CSV and vice versa. So that's a nice one. There's a whole bunch of other stuff. You probably have reasons for doing it as well. But the other one that comes up, obviously, back to writing management tools for your applications, is building your GUI over PowerShell. You've probably for a long time been working with SQL Server Management Studio, and you might have noticed that all the wizards and all the designers that you create tables and do a restore database all have a button in the corner that says save as script, and it spits out a new window with a whole bunch of T-SQL which is going to do that operation for you. And then you can save that script away, change some of the parameters, put it in a loop. That same thing has been happening for a while. Windows Server 2012 AD Admin Center and the Server Manager is now all that. System Center Virtual Machine Manager, Microsoft Exchange Management, all that sort of stuff. The IDE that you use, or sorry, the GUI that you use to manage those applications is just a shim over the PowerShell module. And everything you do in that is under the covers running the PowerShell commandlets. And they're all now exposing buttons. You can click Save, and it spits out a PowerShell script that configures that application or that server for you. Server 2012, you click Promote to Domain Controller, fill in all the boxes, and the last button you go Save, and it gives you a script to promote a machine to a domain controller. Awesome. Question?
I know you're not running a domain controller or anything like that. One of my friends was telling me ages ago about this, how fantastic it is. He's just an IT admin, he clicks Save, suddenly he's got this PowerShell script. Can you actually show us how that works?
I do have a domain controller on here. I haven't.
Like later? Like?
Perhaps. We'll see how we go.
All right, awesome.
So this is becoming common, and it's very useful because then it gives the infrastructure people the ability to put those scripts away for keeping an audit trail or being able to see how things have changed over time. And as we move towards a model of having fewer unique snowflake servers where nobody dares touch it because they don't know how it's set up, to the model where we just everything's scripted. You just throw that server away, spin up a new VM, and run the script, and away you go. That stuff becomes a lot more important. And as the quantities of machines happen, you get an Azure environment where we start talking about farming out across multiple nodes, being able to take a script to configure one machine and just run it on all of them, rather than sitting there on the mouse for half a day. Great. So that's another good reason why you might do it yourself. But there are some things to consider when you might host PowerShell, because you can actually load the PowerShell hosting system into your process and deal with it, pass objects in, get the objects come back. Or you can just shell out to PowerShell.exe, give it a bunch of commands, let it run. Maybe you capture the output stream as text. It depends on what you want to do. And there's gotchas both ways, but I'll come across that in the demo. So, hence the demo. Now, the first one actually starts off with the tests for the app harbor commandlets. And the first place I want to go, I've got it written down here somewhere. So, boring test framework, it's probably MS test. I'll show what's going on behind in this function in a moment. But basically, I'm spinning up a PowerShell object. It's called PowerShell. I add a command to it. There's a little bit of magic going on here too, which I'll reveal shortly. I ask the shell to invoke the command that I just added to it, and it gives me back all the objects that normally would have come out of that command and onto the screen, but it comes back to my output. And then I'm just checking in this case that I get more than one, not 0 objects, and that they are application objects. I'll reveal the magic here. The irony is that while PowerShell is a beautiful system for working with objects instead of trying to muck around with string parsing, when you host it, you're parsing strings. And so the real shell add command actually takes the name of the commandlet you want to run as a string. But because I'm writing tests against commandlets I've written, I'm doing a little bit of reflection to grab the attributes off my class to work out what the get is and what the noun is, and then just join them into a string and pass them through that way so my tests don't fail due to silly typing errors. And the other one, we go back here. Let's try the test again. Oh dear, it's going to be one of those. All right. This is the function that spins up the PowerShell object to do the invoking. And it's literally PowerShell.create. And PowerShell lives in the system management automation namespace from that reference I enlisted before. So yeah, in this case, I've got a bit of it tucked away so I can create the shell, run the import module command so it's in the scope, invoke it, clear the commands, and then return that back so I can run some more commands that actually hit the module. This is in the context of testing a module I've written, but it's exactly the same for actually hosting PowerShell yourself, which I'm just going to copy and paste here. No, it's not going to let me copy and paste. Awesome. It'll take a little while. Aha. And here we are, very simple. We have a person, name, age, real simple. And I set up a few instances of that in an array, just a few examples. Data may or may not be accurate. Now, I know that when I call convert to CSV in PowerShell, it's going to give me some strings back. One string per line of CSV. And so I've just set up a generic type string. And then I create the PowerShell, I add the command convert to CSV. I'm setting an additional parameter called no type information because PowerShell's convert thing likes to stick a top comment line on the CSV about the types of the objects it's serializing, so when you round trip it can do a better job of rehydrating. And then I invoke it and pass it my array of people, and that basically gets pushed through the pipe, and then I read out the results. So should just be able to run that one. And of course it comes up on the other window. And there we go. So it's doing the whole CSV rendering for me, the header line with the names of the properties, and then the values for each object. I didn't have to import anything. It's going to work on any system that has PowerShell v2, which should be anything Windows 7, 2008, R2 or later. And it's just in the box, but it wasn't in the .NET framework. So it's like taking a dependency without taking a dependency. There's nothing more to that code. Where it does get interesting is whether you want to host PowerShell like I've just showed you, or whether you want to shell out to it. Obviously, if you want the objects back as objects, you need to host it. However, in the case of TFS deployer, where people are writing arbitrary PowerShell scripts that go and do a whole bunch of stuff, they might call out to a native app which is going to try and interact with the standard input and output streams in a certain way, and they expect a console window to exist, which doesn't exist when you're running hosted PowerShell in, say, a web app. And so you might have to go and do it that way. And I've got some example code of that, which hopefully will be fairly easy to navigate. Watch out, guys, this is actual production code. So I'm going to start with the PowerShell agent runner. Okay, Resharp is not playing today. It's gone! All right, never mind. Let's see if I can find this class. Yeah, I know my code base. That might be a little big, huh? All right. So, a couple of different things going on in here. To start with, I'm taking in a request object, and I need to turn it into a command line somewhere. No, I don't. In this case, I'm actually, to avoid dealing with the arguments, I run a named pipe server and client on each end, so I can just push them straight through to another process. And then I basically spin up my process here. I use an async reader, so I can read the output stream and the error stream and just flow them through as it happens. And I wait for it to exit, and everything's all over. But that stuff's not so interesting. Where it's actually happening is over here. So I start by getting the request in and turning it into a bunch of arguments. Here it's just an array, which again aligns with the main args array in the effectively PowerShell.exe. And then there's a console shell class, which is effectively exactly what PowerShell.exe starts up as soon as it's finished loading the CLR of your choice based on the version. And so I just pass in a configuration object, which you can use to pre-configure the environment or to set up, I think you can even use it for remoting. Haven't tried that one. And then the args array of what you would otherwise be passing to PowerShell.exe. And so this program just exists, so instead of calling PowerShell.exe, I can use named pipes to get the args over. Yeah. So there'll be dragons if you do have to go down that one. But the TFS deployer source is all open and on Codeplex if you really do want to do that and want to catch how it works. But other than that, thanks for your time. Any questions? Yes?
In the example where you're hosting PowerShell, you register the commandlets that your application supports.
Yes. So in the case, when I'm hosting PowerShell. Yeah, when you host PowerShell, you need to set up a run profile. By default, you're just saying, hey, assume a vanilla PowerShell instance.
If you want to pop up the console window and use some type of command that's in, that would say access the objects within your application, iterate over them and call the methods. You have to sort of expose those.
Yeah, so that would be a little bit different. So on one hand, if you were hosting PowerShell and wanted the live objects in your application to be able to be used by by PowerShell, you would either be loading and running a pre-written script, or you'd have to write your own GUI to provide the user with a script editor and a runtime environment, much like how the NuGet Package Explorer works in Visual Studio. And in that case, you would set up a constrained run space when you create the shell and say, these are the limited amount of commandlets that PowerShell is allowed to execute. And you would have to push some objects, I think, across an app domain boundary to say, this is what you have access to. And the PowerShell ISE itself actually operates like that. The WPF implementation of the ISE exposes a bunch of objects through to the console, so you can actually manage the ISE itself. The other side of that, if you wanted an active PowerShell exe console, as someone's just started and be able to access something in an application, you would have to write a module. The user would import that module into that session, and then that module would know something about how to talk to your application. It might use web services, like the App Harbor example. It might know that the application's on the same box and use shared memory or named pipes or something, but that's between your module and the application. Any other questions?
How simple would it be to show an example of outputting a PowerShell script from doing some management? Like, is that really simple?
It's simple, but I've got to boot up all the VMs.
No problem.
So maybe afterwards.
Is it easy to talk through? Like, do you literally is it the same as Management Studio where you just?
It is exactly the same as Management Studio. You walk through the GUI,
yep, doing
whatever it is that you want to do, and on the last stage where it says finish,
yep,
there's a button that says save, or the button is save is after it's finished. Either way, the button is there once you've made all the decisions about what it is you're doing, and you just click save and it gives you a script. It's that simple. Yeah.
Do you know if it's compatible with PowerShell? Sorry, PowerGUI?
PowerGUI. I haven't used PowerGUI since the early version 2 days, but I know those guys have been pretty good with staying up to date with stuff, and I would expect PowerGUI to be available in a version 3 option by now. Yeah. Cool. All right, well, thanks again for listening.